acceleration. And so
It says fictitious force, doesn't it, in it?
yeah,
But it's because that's a concept, it's a theory.
I
To explain relative
really,
movement.
yeah, it's really annoying that it's called a fictitious force, because I think that the
Yeah.
perfect word for it is inertial force, which is kind of a word a lot of people, not a lot, but some people do use it. Like, it's even on the Wikipedia page that it's referred to as an inertial force as well. But I feel like that captures it way better than calling it fictitious.
I think it's a force. I think it's what was I going to say? Relative movement.
Yeah.
Relative movement relative to rotation.
Yeah, but the thing is that anything that makes something seem like it's accelerating is almost by definition a force, because force causes acceleration. And so that's why we kind of would still call it a force, but we kind of put in the caveat that it's not a force caused by some sort of interaction. It's just a force, as in like an acceleration that happens because of a reference frame. And that's
what
why
does inertial mean as a word?
So inertial means that it's essentially, if it's inertial, it's not accelerating. So it's like a non-changing reference system.
So it's
essentially.
Like apparent acceleration.
Wait,
relative acceleration.
It kind of, yeah. Can almost look at it that way, yeah.
Because if it means non-accelerating, it would be non-accelerating force. And your definition was the force is accelerating. Accelerating things is a force.
Yeah.
I think it's just a type of relative movement.
Yeah, but that's the thing, is you're correct on that. We just decided that we call that a force because anything that causes movement is a force. Right. And then we put in the caveat that it's not because of an interaction, it's just because of relative motion. It has to do with the fact that from one position or from one reference frame you're accelerating, from the other one you're not. So you are right, but it's also kind of like it is captured within the definition. It just isn't as apparent as it could be.
Yeah, I'm a layman, so I don't know what lingo is accepted and what all the words mean in the context.
Yeah. But essentially what you're saying is what I mean when I say inertial force, is that word inertial means that one thing is accelerating differently to the other thing, and that's why we're getting acceleration. Which is essentially, of course, the same as saying relative movement in a way.
It's weird. I was just thinking about it because some examples, spinning actually makes things physically move away from the spin, like the spinning a ball with the water on it, or a merry-go-round where when you let go or lose your grip. But some Coriolis just apparent movement because of the reference frames.
Well, so the thing is, when you're spinning,
the spin isn't actually making the bullet move. Is it the shooting the bullet's making the bullet move, and the Earth's moving under it?
Yeah, but the thing is, when you spin something and it makes it move out, that's actually like it. At the same time, it's not actually making it go out in that way. What you're actually doing is you're giving it linear speed, so it wants to just shoot out straight forward, but then you keep it attached in whatever way. And the fact that you're keeping it attached means you need to continuously pull on it. Not what makes it feel like it's pushing out is because in order to keep moving it back to you, because it just wants to shoot straight. It wants to move straight, not in a circle. It wants to just move straight, continue its motion. So the fact that you're pulling it back into this motion of a circle, that is what makes it feel like it wants to go out, because technically it does. It wants to keep moving in the same direction it's moving.
Wouldn't you agree? Some examples of Coriolis are actual relative movement, and some examples of Coriolis are apparent relative movement.
I'm not quite sure what you mean by that.
So, like on a merry-go-round, when you let go, you're physically pushed outwards from the spinning object.
Yeah, but that's what I'm saying is the fact that you're physically pushed.
When a bullet's fired across Earth, the spinning of the Earth isn't making the bullet move away from Earth. The bullet's on its own track, and the Earth's rotating underneath. Isn't that right?
Yeah.
So there's two examples: one with physical movement and one with apparent movement.
So, but the reason why when you're on the merry-go-round, where you're feeling the physical movement of you being pushed out, is because you're physically connected to the floor. If you were to,
one's connected, one isn't connected.
Yeah. If you were to somehow be able to disconnect from the floor and just jump while you're on the merry-go-round, you'd act exactly like the bullet.
Yeah.
But the fact that you're still attached is what makes that feeling of you're being pushed out. Because the merry-go-round is still there trying to pull you in the circle, but you're trying to move in your linear direction. And that's what makes it feel like you're going out.
Yeah, I get that now.
Sorry to interrupt, guys. Do you remember the exact words that Moyak used? Was it illusionary wind? Imaginary?
Yeah. Illusionary, yeah.
Illusionary. Okay, thank you.
Oh, you're going to have fun with that one, huh?
Oh, I'm making a meme right now as we speak.
Listen, come back sometime. I gotta have Moyak show you these triangles, 3 triangles things he's got going on.
I'm dying to see that, Jeremy, bro. I'm dying. Yeah.
But yo, you could run a stream back. Live stream off. What's the red dot mean? That means it's off, right?
Oh, he said he already said it. Yeah.
If we're on YouTube though, you can run the stream back.
Right.
I don't know if the stream's live though or not because there's a red dot on the top. So I don't know if Gio shut it off or it crashed or what happened.
Yeah, I was thrown off my chair when I heard that illusionary wind. Wow, that was something.
That was a good one. Yeah. The thing is with this Coriolis thing, like if you're going hemisphere, which way does the Coriolis push you? I forgot. Does it push you?
The physical Earth rotates. What is it? Counterclockwise?
It doesn't really push you.
The Coriolis effect has a specific directionality to it.
Yes.
In the northern to southern hemisphere.
Yes.
Can I ask about the illusionary wind thing? So
should ask Moyak.
No, I want to ask you because
why are you going to ask him?
Because you're criticizing the term, so I want to ask something related to it.
It's funny to me.
Yeah. But can I ask you?
It's not a criticism. It's just funny.
Well, when you're going in a car and you put your hand out,
illusionary has a meaning. That's why it's funny.
Okay.
You know, right? Illusionary has a meaning, right, Gummy Bear?
Sure.
You know what it means, illusionary.
I mean that it's just an illusion, not real.
All right, then why would I talk about something that is an illusion as a real thing, or why would I argue about it? It's just funny.
And that's why I'm actually giving you a context in which.
Let's hear the context. I can't wait to hear this.
So when you're walking to your car and you don't really feel any wind, there's no wind. Then you get in your car and you start driving, and you put your hand out the window. Now it feels like your hand's being pushed along. Like the wind, there's a bunch of air pushing your hand. It's almost like there's an illusionary wind. It's not there when you step out of your car.
What?
But while you're driving, it seems like there's a wind.
You mean there is actually a wind? The real wind?
No, because when you're outside the car standing still, you feel no air movement. It's completely still. But while you're driving and you put your hand out the window, oh no, you're feeling wind. It's almost like there's an illusionary wind.
No, that's not wind you're feeling. You're feeling you rushing by the atmos. That's not the same
What
thing.
do
A
you call
wind
it?
is when you're stationary and you feel a wind. That's a wind.
But that's almost like you could call it an illusionary wind because it
No,
feels
you
just like
can't.
a wind.
No.
It feels just like a wind is, but it's not a wind.
No, it's your car traveling causing that. It's nothing illusionary about it.
And that's the exact thing that when Moya was talking about the plane, that's the exact same thing. It is a wind that is felt only because the airplane is moving, not because there's an actual wind. It is the exact same thing.
No, nice try, but that's not
No,
what he was saying.
it is.
No.
I promise you it is. If he was
So
here,
you know
he'd
what's
agree
in
with
his
me.
mind. You know what's in his head.
Yes.
It is.
If he was here, he'd agree with me. I'd bet $1,000 on that.
Sure.
Yeah, literally, I would.
So okay, so how does it
hang on.
cause the movement of the plane to change then?
I've got a
Because-
concept. Yeah, you're in a car with an open top,
Okay.
and you're a dog, and you're in the illusionary wind and the real wind at the same time. Boom.
Yeah.
Wow.
So how does it make the airplane change direction? Well, when you put your hand out the window, it still makes it push back, even though it's just an illusionary wind. It still makes your hand want to go back.
You might want to use a better term for that. Relative wind is the term used in aviation.
I know, but it's because a person used the word illusionary wind, and I'm just continuing it because it's funny. Because it is still kind of accurate.
So this illusionary wind causes what? Who was it that was asking? He was asking. So this illusionary wind therefore negates the movement of the ground somehow. That was the original question.
No, it doesn't negate the movement of the ground. It changes the speed of the airplane.
So is the ground moving underneath the plane?
Well, the ground is moving, but it is also possible for the airplane to be moving relative to the Earth in lockstep.
In lockstep. Okay, so let's say we're on
Correct.
the equator. The equator is traveling at 1,000 miles an hour. The plane is moving at 500 miles an hour. You're going to tell me
Okay.
we won't be able to see the difference between the plane movement and the ground?
In what direction and in relation to what? That's not quite enough information you've given me.
Sure, no problem. Your Earth rotates at 1,000 miles an hour at the equator, correct?
Yeah.
Now, the atmos is velcroed along, moving along with your Earth at the equator at 1,000 miles an hour, correct?
It's a little bit less correct, but it's kind of correct.
What do you mean, kind of correct?
Well, first of all,
Velcroed
first of all, it's not velcroed along, and second of all, it wouldn't be moving at exactly 1,000 miles per hour. The higher up you would go, it would be moving a little bit faster, and a little bit faster. At ground level, sure, it would be moving at pretty much 1,000 miles per hour. Yeah.
Okay, so now the plane in that atmos, it's traveling in the opposite direction,
Okay.
right? You're going to tell me now the plane is traveling at 500 miles an hour relative to the spinning atmos and the Earth, which is together. You're going to tell me you don't notice any movement of the ground going at 500 miles an hour difference to your plane?
Of course you are. You're going to be moving at 500 miles an hour over the ground. The ground is going to be scrolling beneath you at 500 miles per hour.
Really?
It's almost like you could say that you're stationary and the ground is moving beneath you at 500 miles per hour. It's almost like there's two different reference frames which you can look at it from.
Okay, so he asked you to put a camera. He asked you to put a camera on the plane and show this. But you seem to have been having a problem with that.
No.
You're saying he was saying only a bullet.
No, that's not.
He was
that's
saying
not
only
what
a bullet can.
The question he was asking wasn't whether you'd see the ground scrolling backwards as you're flying forwards. He was asking whether you would see it scrolling sideways at you as
Whichever
you're
way,
moving.
yeah, of course. Whichever way you're moving against the motion, yes.
No, so he's saying is not whichever direction you're moving against. A different. So if let's say in his scenario, you'd be moving like straight north, and the ground would still be moving left to right. That's
Okay,
his
so how would
example.
your plane adjust for that movement? How would you be going straight then?
Well, you'd have side wind.
The wind would cause you to stay, because don't forget, when let's say you start off at 0, right, at your pole in the north, you have no
Yeah.
rotation there. And as you travel downwards in your mythical ball, it slowly goes up. Like around Canada, they say it's 800, and then in the equator, it's 1,000.
Yeah.
So how does the plane differentiate between these speeds? What happens if it's flying north and south?
Well, because it's getting side wind. That's making
Side
it
wind?
go. Yeah. So you know how in the car, when you hold your hand out and you're accelerating, the air is making you want to slow down. If it's the other way around, where the wind is moving faster than the
So
car, well, then it's
drag.
trying to make you speed up. That same
Drag
thing works.
happening.
Pretty
You're
much
saying
drag.
drag.
Yeah.
Drag, okay.
So you're saying the wind makes the plane fly slower, faster, left, right. It's the wind that does that.
Well, again, the same discussion we had earlier. Would you call what happens when you stick your hand out the car? Would you call that wind, or is it drag?
You can call it whatever you want. You're trying to make
But
up a
that's what is.
mythical force.
That is what's
Hold on.
happening. Yeah.
So this mythical wind is actually what's keeping the plane straight, and at the same time preventing you from seeing a 500-mile-an-hour difference between your reference frame, let's put it that way so you can understand, and the ground. It's the wind.
It's not the wind preventing you from seeing that. It's the wind preventing that from happening in any other direction than the direction of movement.
Makes absolutely no sense. Does anybody get what he's saying here, or is it just me?
Even you get it. You're just pretending not to.
So you get it what he's saying too, Don?
Yeah, simple.
Yeah, we all get it, FC, and you do too.
Okay, 5 minutes ago, Don told me sometimes the clouds are, or sometimes the Earth is rotating under the ISS, sometimes it isn't. Another day, Bob, you told me clouds are made of water vapor, so you guys don't fucking get it.
Well, clouds are made of water vapor, and
No, they're not. That's dumb.
I have no idea what you're talking about with the ISS.
So with
Realize-
all we were saying is that because the ISS is moving in an orbit, at some points it might be matching the speed of the rotation, at some point it isn't, and therefore you can kind of, if you want to, look at it as sometimes Coriolis isn't happening and sometimes it is, because sometimes it is moving in lockstep with the rotation and sometimes it isn't. But it is a kind of unnecessary thing to talk about. But it does happen if you look at it that way.
Okay, let me drive home your fantasy now. Same scenario. We're traveling east to west against the 1,000-mile-an-hour wind.
Okay.
Right? And the plane can only go 500 miles an hour. How is it moving forward?
Because in relation to the ground, it is moving 500 miles.
What do you mean in relate? You said that the atmosphere, the atmos, and the ground move relatively together at 1,000 miles an hour. So you have east-west direction, wind, 1,000 miles an hour, and you have west-east direction of the plane. How does the plane that travels only 500 miles an hour go ahead in a headwind that's 1,000 miles an hour?
It's not 1,000-mile-an-hour wind for one thing. And
well, the atmos
this is
is
how planes
traveling
fly.
at
They just
1,000
fly
miles,
through the
right?
atmosphere that's moving. That's what they do.
Because
FC,
again,
how fast is the airplane moving on the ground if the ground is moving 1,000 miles an hour?
What does that have to do with it? The ground and the atmos are stuck together, right? Are they moving
Literally
together?
everything, SE. How fast is the plane moving if it's sitting still on the ground that's moving 1,000 miles an hour?
The ground is not moving at 1,000 miles an hour.
In your scenario, it is.
That's your scenario. Don't ask me to explain your fantasy.
We don't have any fantasy.
Sure you do. You got a headwind of
There's no
1,000
headwind.
miles an hour. You got a plane that can only go 500.
There's no
Now
headwind
you
at
have to
1,000 miles
explain
an hour. SC.
by which mechanism does it move forward, sir?
SC, the plane is moving 1,000 miles an hour sitting on the ground. As soon as it takes off, it retains that 1,000 and adds the thrust of the engine. And you know that. It's been explained to you many times.
Right. You think you can recreate that in real life?
Every day.
Make a model and show us. Make a wind tunnel.
You
Don't
think
I'd
need
you
to.
love to see
I
this.
don't
Show
need
us how
to.
this
I
is
fly
done.
an airplane. I do it every day. It's not a problem at all.
You do it on a stationary Earth. That's why you don't have a problem.
No, I don't, SC.
Cool fantasy.
Yeah, you guys live in fantasy. I mean, it's obvious you have no answers.
You've been given lots of answers.
You don't have the listening ability.
Look, you say conservation of momentum, right? With the Atmos, correct?
No.
No?
No.
What?
I say confirmation of momentum, but I have no idea what you're talking about when you say Atmo.
Conservation, not confirmation. Conservation
That's what I
of
said,
momentum.
conservation of momentum. I have no idea what the word Atmo means, though.
Sure you do.
It's his
Air,
word.
it means
Instead of
air.
saying atmosphere,
Yep.
because it's a
Use
scary
the correct
word.
If you want to talk to me, SE, use the correct word.
Sure, atmosphere. You know the air that becomes into a sphere magically?
Yeah. The atmosphere, yes. That's the correct term.
So, okay, go ahead, answer the question then.
I did.
No, you didn't. You have an atmosphere traveling one direction at 1,000 miles an hour with your ground. We agreed on that. You have a plane which is only capable of going 500 miles an hour. How does it move forward, sir?
How does the plane move forward? What the fuck?
Yeah,
like you're talking like you have no idea what relative speeds are.
Yeah, you've already acknowledged that the ground is moving 1,000 miles an hour and the atmosphere is also moving 1,000 miles an hour. So the relative speed between the two is 0. We've added a plane that adds 500 miles an hour to that speed. So the plane is moving 500 miles an hour over the ground. And very simple. 8th grade stuff, SE.
Only works in your mind. You think you can recreate that in a wind tunnel? Should be simple enough for you. 5th grade?
Every day,
Go ahead, Bob.
Every day?
A wind tunnel? What are you talking about? Who wants to make an Earth with mini gravity like a magician in a wind tunnel? No one's doing that.
I don't know. I'd like to see.
That's
I'd like to see
absurd
him make
idea.
a cloud. I'd like to see him make a cloud out of water vapor. That'd be fucking impressive. Holy shit! Is that science, Bob? Who told you that? I'm just curious because I've been hearing a lot of people say that shit. I'm wondering where you guys are getting this shit from.
What do you think a cloud's made out of?
Not water. I know it's not water vapor. You know
how do you know that it's not?
You know
water?
how I know it's. You know how I know? Because you can't see water vapor.
What is a cloud?
We see clouds.
You don't see the kettle when it's boiling, that you see the steam rising up.
Water vapor.
Now, what he's trying to do is he's trying to draw the distinction that actually a cloud is little droplets of liquid water rather than water vapor. It's condensation. That's the little distinction that he's trying to make.
So not water vapor then. So clouds aren't.
He's missing the forest because he's looking at a tree.
Yeah.
That's characteristic
so you realize
science denial, and that's inappropriate or incorrect scientific reasoning.
Okay, so you realize we can't see water
and he's
vapor.
also cherry picking, which is characteristic number 1.
So you realize we can't see water vapor, right?
So, Bob, how's your channel going with you having banned everybody? How are you guys getting along talking to each other?
Oh, it's going great. Thanks.
Not so great since you're here, right?
No, I tend to go to a lot of different places, and I've actually taken a break for a couple of weeks. I'm getting ready to make another video today, though.
So Jeremy, what's the difference between steam and vapor? Is steam a vapor, or is vapor a steam?
I don't think you guys let me finish earlier. I was explaining how you can definitely know that clouds aren't made of water vapor. Because you can't see water vapor. It's an invisible gas.
But
and
like
we can clearly see
But
clouds.
Jeremy, I can see the steam coming out of my kettle when it's boiling.
Right. That's not the stuff you see. That's not water vapor, bro.
So what is it?
It's tiny water droplets. You can't see water vapor. Do you understand? This is very simple. Bob should have known this.
Well, and you've decided
maybe
are just the bit you can see. Is that what you've decided?
So the steam coming out of your kettle is what you see is actually not steam. It's just water droplets.
it's not water vapor.
I think Jeremy's right on this
Because
one, right?
I am right. Of course I'm right. These guys are fucking ridiculous, dude.
Yeah, but it's technical semantics. It's not a good
Like
point.
the water vapor when the water vapor leaves like the what do you call when you're boiling water, the thing you use to boil water. Well, that thing when the water vapor leaves it,
Kettle.
it gets colder when it mixes with the rest of the air, and then the water condenses and then it forms droplets. Then you can see it. Isn't that what happens? Like if you try to see the water vapor as it leaves the surface, you can't. It just becomes visible a little bit above the surface where the
You
water
can't see
starts to
water
condense.
vapor. Listen, this is
Yeah,
fifth grade
that's
stuff.
what I'm
You
saying.
can't see. I know this is fifth grade stuff. Bob should have known this. You can't see water vapor. That's how you know clouds aren't made of water vapor, because you can see a cloud. This is like second grade shit, dude.
Okay. So
Clouds are
are you
made out of
saying?
water vapor that condenses.
So are you
Which when-
saying then? Are you saying that there is no water vapor in that steam?
Yo,
you see
show me where it says a cloud's made of water vapor. Does anyone have that? A reference? I got.
No,
NASA
we're not going
saying-
to play with your little distinction games because it's just not relevant.
So-
but thank
so,
you for playing, Jeremy.
Distinction
Brother
game. We're
Bacon.
talking about what something's made of, Bob.
Well, I'm
No,
getting
we're
at
not.
bacon
We're
as
not.
well.
We're talking
and
about
I'm
you
not-
trying to cherry pick
We're just-
semantics.
We're gonna distinct between what it is made of and what it isn't made of. You don't like that?
Yeah, so-
I know you
so,
wouldn't like that. 'Cause
Jeremy-
you
No, we're
said it
not.
was made out of some dumb shit that it's
Well,
not made out of.
Jeremy, what I'm trying to get the distinction of is that sure, what you see physically is the water droplets condensing, but within that there is still water vapor.
Cool. So if I have an aluminum can sitting on my table, water vapor in it, I can say that can's made out of water vapor because there's water vapor surrounding it. This is dumb. This is like so stupid.
It's water vapor.
You guys are the
process
smartest
of
dumb people
clouds,
I ever
Jeremy.
seen.
Jeremy, is water vapor involved with the process of clouds?
So anything that's involved in the process of making something, I can say that it's made of that thing. Is that what we're gonna do now?
Just say yes or no. Just answer, and then you can ask your question.
There's an anvil, dude. This is
say
ridiculous.
yes, Dawn. Of course, it's involved.
Okay. How about this then? You get your cup of coffee, and then you put sugar in it. Putting sugar in it changes nothing about what you see, but there is still now sugar in the coffee. I would say that coffee is made of sugar because there is sugar in that coffee. It is also made of coffee grounds and boiled water.
Listen,
but just because you don't
tell me where
see
you
the
guys-
sugar, just because you don't see the sugar doesn't mean it's not made of it. It's still in there. You just don't see it.
Okay, who told you guys the cloud's made of water vapor? Who told you that?
Who told you coffee is not made of what you don't see?
Forget about the coffee. Who told you a cloud's made of water vapor? That's all. I'm just wondering where you got this from, because I know where I got my stuff
my
from.
grandpa said that.
Okay,
So
I know
I
where I
trust
got
him.
my thing from.
Okay.
I know who told me what clouds are made out of. I got places like NOAA, NASA, all kinds of scientific places. I'm just wondering who told you guys the thing you're saying. Your grandpa?
I googled the first define cloud, and the first definition says visible mass of condensed water vapor floating in the atmosphere. So I
yes,
guess
you know what condensed water? You know what
Yes,
condensed
yeah,
water vapor is?
yeah, it's the water droplets you're referring to. I know, I'm aware of that.
Yeah,
But
or condensed water vapor, which is liquid.
but the thing is,
Which water vapor isn't liquid, right?
the thing is, if you had a cloud of just water vapor, right, it would condense and form water droplets. So you would have both. Like, I don't think you can have one without the other. So it's just as like it's basically the same thing. You won't have a cloud of water vapor at high in the sky that is not condensing, and you're not gonna have
for a cloud.
and you're not gonna have a bunch of water drops suspended in the air without the air in between them being humid or having water vapor. So I think you can't have one without the other. Then it becomes just a semantical discussion, I think.
Exactly. That is what this is all.
So like that doesn't sound like either of you guys is wrong. It just sound like this discussion is
Okay.
sort of pointless.
Since I think Jeremy at least would like to move on because Moyak is here and Jeremy is biting at the bits for his triangles.
Well, the bottom line is that water vapor is a necessary antecedent to a cloud. You can't have a cloud without water vapor, period.
So whatever something is made of, so you're saying, so I could say something's made out of molten aluminum because the thing's made out of aluminum.
Move on, Jeremy.
Clouds aren't made of water vapor, dude. That's dumb.
Move on. Water vapor.
Of course you want to move on. Of course you want to move on.
Okay, no, Jeremy, if you throw a vat of molten aluminum into the air, then yes, for a moment it is partly molten aluminum, partly solidified aluminum. You are correct on that.
Okay, since we might be agreeing on what a cloud is made of. Can we move on?
Is it made of water vapor?
Let's move on.
Do you think a cloud's made of water vapor?
And water
All right,
droplets.
this is a pedantic argument
So I can
that doesn't
say
get us any further.
We said it's both.
Made of water. I can say an ice cube's made of water vapor. You guys would be cool with that? That's water vapor.
It's a pedantic argument that gets us nowhere.
That's a difference. There's no water vapor in the ice. There is water vapor in the clouds. You don't have suspended droplets of water without water vapor in between them. You can't have dry air and suspended water droplets.
You can definitely have water vapor you can definitely have water vapor inside ice. You never seen air bubbles inside ice?
Oh yeah, you can have, but that's no ice.
So if I have an
ice
ice cube,
so
if I have an ice cube and there's a water vapor molecule in between it, that I could say that ice cube is made of water vapor.
No, because
if there's a little piece of
something beneficial,
if there's a tiny piece of lint,
I know it's
just
dumb to say clouds are made of water vapor. We should move on.
If there's a tiny piece of lint inside your ice cube, you don't say that the ice cube is made of lint. Just because there's a tiny amount of something.
Difference.
Clouds are made of water droplets, not water vapor. Clearly, that's a liquid, not a gas.
There's a more important difference.
Well,
yeah, there's a more important. You can't have one without the other in the example of clouds, but you can in the example of an ice cube. You don't need to have water vapor bubbles inside of the ice to have ice.
Okay, you can't grow wood. You can't grow wood without water. So I could say, when I look at my shed that's made out of all wood, I could say that's made of water since you had to have water to make the wood. This is dumb
because
what you guys
the water.
are saying.
Because the water.
Ridiculous.
No, it's not analogous.
You guys are saying dumb things.
Let me answer. Stop saying it's dumb and allow the answer. So you can't have wood without water there. You can't have a cloud without water vapor. Your example is just not backing that the logic.
Wood without water. You think you can have wood without water?
Jeremy, what's your point?
You can't have wood without the wood having water.
Clouds are a combination of water vapor and droplets and phase transitions of water. Okay, is that good enough?
Yeah. We didn't claim water vapor is part of the definition of a cloud because it's where it comes from. It's because it's there. So in the example of the wood, the water isn't there anymore, and you still have wood. So it doesn't make sense to define the wood as being made of water, because you can have wood without having water on it.
You guys are saying since we can't have the water droplets the clouds are made of without water vapor, and you can't have wood without water. Okay, can you grow wood without water?
Jeremy, what's your point?
It's a necessary antecedent. Bob literally used this phrase earlier. It's a necessary antecedent to having water.
We're talking about the composition. That's not an analogy. Because you're not talking about
something.
Yeah, but we're not talking about
We
it
have
being an
this thing, and the
antecedent.
necessary
That's not the
antecedent for that
point.
thing is the X.
But that wasn't the
I'm
argument.
saying I have something.
That was not the argument. The
Okay,
argument
go ahead.
was
I'll go
not
when
that.
you're done. I'll go when you're done. Go ahead, bro.
Right. The argument was not that water vapor is an antecedent to the water droplets. That was not the argument. If that was the argument, you'd be right. Your response would make sense. But it doesn't make sense because that was not the argument. The argument is that in the composition of the cloud, you have both, regardless of the antecedent.
That you can't have the stuff the cloud's made of, the water droplets, without water vapor. It's a necessary antecedent. That's what he said.
Yeah, but that's not what we're saying right
Yes.
now.
Okay. Yes, that's what he said.
But
so you can't have wood without having water because wood requires water to grow. Right? Is the water the necessary antecedent for wood?
if you're arguing about the antecedent argument, I'm with you. But that's not what I'm saying.
With me. Okay, so
Wood
water's
is
the
made of
necessary
Are both of them made of
antecedent
water?
for wood.
While it's alive.
Is wood made of
partly
water? Is wood
Yeah.
made of water, or is that a constituent part that goes into
Yeah, but
creating?
the thing is, Jeremy
There's
was
water vapor and water droplets.
There's water
are the
in
same
wood.
thing.
There's water in wood.
Yeah, but water vapor and water droplets are the same fucking chemical.
What?
Water vapor and water droplets are the same fucking chemical.
Well, I don't think
The
that's
water that's in the tree.
that's not a I don't think that's a valid response, Moyak. But
Why not?
Jeremy, where's the water in the tree now? Where's the water in the wood?
It's in the tree. There's water. There's water in the wood.
Yeah, but where's the water in the wood? What does the water become in the wood?
It's not important. The necessary antecedent
Yes,
to having wood is water.
Question.
Right? Is the Can you have wood without
Answer
water?
the question. What is the water in the wood?
Squeeze it
What
out.
does
Can
the
you
water
get a
become
piece of
in the wood?
Can you get
I
a
mean,
piece of wood and then
that's
squeeze
not
the water out of
important.
the wood?
If that's not important, you can point it out. But at least answer the question. Let's see where he goes with it.
Squeeze the
What
water
does the
out of
water
the. I
become
can
in the
squeeze
wood?
press the wood and get water out of the wood. So
What
I don't know
does
what's
the
in there.
water become in the wood?
Piece of wood. Can
You're
squeeze
right.
the wood and get.
It becomes the
piece of
wood.
wood.
It's no longer
Shut up.
water. It's cellulose.
Can I respond, please?
No.
You're saying it becomes something else because I can have a piece of wood.
Yep.
And then I can there's water in it. I could cut the tree down, cut it into little 2x4s, squeeze the 2x4s and get more water. So there's
If it's
water in there.
completely dry, is it still wood? If it's completely dry, is it still wood?
When is it? So you're saying there's no moisture in this wood at all? Zero moisture.
Is it still wood?
Sure. Where did we get wood like that?
Kiln dried wood
Created by a chemical reaction.
All right, we're way off the reservation here.
Yeah,
The point is you can't say that something's made of something just because you needed that thing. It doesn't matter about the necessary antecedent. Yeah, the necessary antecedent is a ridiculous argument. Okay, we know clouds are not made of water vapor; they're made of water droplets, ice crystals, dust particles, liquids and solids, not gas.
And water vapor.
Who told you that? Your grandfather?
No, you simply can't have water droplets suspended in air without having water vapor in between them.
Clouds can't form in the absence of water.
Water vapor is in between something. You can say that thing is made of water vapor.
Water vapor is required to form clouds. You can't have a cloud without water vapor.
So and you witness this. You witness this in the fact that the clouds change in shape. The whole time they're up there, their phase changing as the temperature and pressure change. And they're in constant state of flux. There's water vapor interlaced between all of the little droplets of water.
Yeah. So yeah, you have the floating humidity.
Or just bring up the citation or whatever you got. That's all. I've never seen it, and I looked for it for a long time. That clouds are made of water vapor.
So you think the air in between the droplets of water?
I don't care what you think. It doesn't matter what your grandfather told you.
I wasn't finished. I just want to know. I just want to know what you're picturing there. So do you think the air in between the water droplets can be completely dry? Like 0%?
It doesn't matter. It doesn't matter. I thought you were done.
Yeah, I want to know the answer for the question.
Oh boy.
Can you answer that question? Then you can say whether or not you think it's relevant.
Sure. I don't care. It doesn't matter what I think. I don't care. All I want to see is where you guys are hearing this stuff. Because I know where I heard my stuff from. NASA told me, and NOAA told me. A whole bunch of like these big scientific places told me what clouds are made out of. And I always
Reading
see it
something
be a
and
liquid or a
understanding
solid.
something are not the same thing. And you
I always see them tell me.
You're clearly demonstrating you can read something and not understand it very well.
Every time these places tell me what the clouds are made of, it's always a liquid or a solid. It's never. I never hear them say a gas.
What you're reading?
Well, who told? Well, where'd you get a gas from?
Yeah, I just found. If we are to form a cloud, humidification may eventually bring the air within the parcel to saturation. Saturation is relative humidity is 100%. So the relative humidity of the air inside of a cloud is 100%, which means there's as much water vapor in the air as you can have without it condensing. Does that make sense now? Because if the humidification of the air is saturated, it can easily condensate. So you would
just read me the part. Okay, just read me the part back where it said what the cloud was made of.
Yeah, okay, I'm gonna read it again. If we are to form a cloud, humidification may eventually bring the air within the parcel to saturation. At saturation, the relative humidity is 100%. So you know what
where's
that
the part
means,
where
right?
it said the cloud's made of? I still didn't hear it.
It's describing a cloud.
Because you're not listening, Jeremy.
You're going to say the cloud's made of, and then there's going to be words after that part.
It's describing what a cloud is. I can keep going. I
the
think
cloud is made up because I can find my people saying, not my people's, but your guys' people saying the cloud is made of, and then there's words after that.
What is 100% humidity, Jeremy? What does that mean?
Bob, can you find me the place that says clouds are made of, and then
you just heard it.
The thing you're saying.
Just heard it. What does 100%
I didn't hear the part
Jeremy?
where it said clouds are made of.
He gave it to you.
Yeah,
I never did use those words at all. Those words weren't even in there. Nothing like those words.
It's not using those words, but if you have any capability of interpretation, you can see that it's describing what a cloud is.
It didn't sound like it meant that they were saying that clouds were made of.
He doesn't know what 100% humidity means. That's the problem.
I think he's just ignoring it, actually.
Yeah.
I'm not ignoring him. I'm waiting for the part where you guys give me the thing that says clouds are made of.
Look up what 100% humidity means and get back to us, Jeremy.
Back to me when you have something that says what clouds are made of.
Just it.
Well, it really depends. You're also talking about what are clouds made of. There's the visual portion of what clouds are made of, the little droplets.